What if I told you that the entire 80-year history of the information technology industry, everything from the room-sized computers of the 1940s to the smartphone in your pocket, wasn't a straight line of progress? What if it wasn't a steady march forward? Instead, what if it was a violent, cyclical oscillation, a battle of ideas, a philosophical war fought in code and silicon? Imagine a giant pendulum swinging relentlessly back and forth between two opposing poles. On one side, total centralized control. On the other, radical decentralized freedom. For nearly a century, this pendulum has defined our digital world. It's the hidden rhythm behind every app you use, every file you save to the cloud, and every device you own. And today, we're going to understand its swing. Hello and welcome to Mindcast. I'm your host, Will. On this show, we decode the powerful ideas that shape our world. And today, we're tackling one of the most important and least understood stories of our time, the secret history of computing architecture. That concept I mentioned, the architectural pendulum, comes from a fascinating analysis of the IT industry. It argues that beneath the surface of relentless innovation lies a fundamental, unresolved debate. Where should our data live? Where should our programs run? Should power be held in a central fortress or distributed to the millions at the edges? This isn't just a technical question, it's a philosophical one that has dictated the rise and fall of tech empires. Today, we live in the age of the cloud. Our photos, our documents, our digital lives are stored on servers owned by giants like Amazon, Google, and Microsoft. It feels inevitable, right? But it wasn't. It was the result of a decades-long war of ideas. So in this episode, we're going to journey back in time. We'll meet the prophets who dreamed up our digital reality long before the technology existed. We'll witness the great tug-of-war between centralization and freedom, and we'll uncover why the triumph of the cloud is about so much more than just technology. It's part of a silent reformation that is fundamentally changing how we think. By the end of this episode, you will not just understand the history of your digital world, you'll understand the why. Key Insight 1: The Prophets of the Digital Age. To understand where we are, we have to go back to the very beginning, not to the 1990s, not to the 80s, but to the aftermath of World War II. The foundations of our hyper-connected world were laid by a handful of visionaries who saw the future with stunning clarity. First, there was Vannevar Bush. In 1945, while the world was still reeling from global conflict, Bush was worried about a different kind of explosion, an information explosion. He saw that science was producing a mountain of research, and our old ways of organizing it, like alphabetical indexes, were completely inadequate. He famously said we were staggered by the findings and conclusions of thousands of other workers. His solution? A hypothetical device he called the Memex. Imagine a desk where a person could store all their books, records, and communications on microfilm. But the genius wasn't the storage, it was the retrieval. Bush realized the human mind works by association, not by rigid hierarchies. So the Memex would allow a user to create associative trails linking different documents together. You could pull up one item and it would immediately pull up the next one you had linked it to. Does that sound familiar? It should. Bush, in 1945, had just invented the core concept of hypertext, the very idea that makes the World Wide Web work. He was the grandfather of the hyperlink. Then, in the 1960s, came J.C.R. Licklider. If Bush imagined how we'd navigate information, Licklider imagined how we'd connect with it, and each other. At a time when computers were seen as giant, impersonal calculators for batch processing, Licklider had a radical vision he called man-computer symbiosis. He saw a future where humans and machines would work in an intimate partnership, with computers acting as extensions of our own thought processes. But he knew this symbiosis couldn't happen in isolation. It needed a network. So in 1963, in a memo that sounds like something out of a science fiction novel, he addressed his colleagues as the members and affiliates of the Intergalactic Computer Network. This wasn't a joke. It was a blueprint for a global, interconnected system where anyone, anywhere, could access data and programs. He envisioned an electronic commons open to all. As a director at DARPA, he put money where his mouth was, funding the research that directly led to the ARPANET, the forerunner of the Internet. Finally, and perhaps most prophetically, there was John McCarthy. In 1961, this titan of artificial intelligence gave a speech at MIT. He looked at the early technology of time-sharing, where multiple users could access one giant mainframe computer from dumb terminals, and he extrapolated. He made a declaration that was, at the time, completely audacious. He said that one day, computing would be organized as a public utility, just like the telephone system or the electric grid. You wouldn't need to own a powerful computer. You would just plug into the wall, use as much computing power as you needed, and be built for it. He called it utility computing. In 1961, John McCarthy had just perfectly described Amazon Web Services, Google Cloud, and the entire business model that dominates the 21st century. These three men weren't just engineers, they were prophets. They laid the intellectual scaffolding for everything that would come next. It's worth pausing here to truly absorb the weight of these predictions. These men weren't just making small, incremental forecasts. They were articulating foundational, paradigm-shifting concepts that would take more than half a century to fully materialize. Vannevar Bush wasn't just thinking about a better filing cabinet. He was fundamentally rethinking the very structure of knowledge. His Memex was a direct challenge to the linear, hierarchical thinking imposed by centuries of print. He saw that the human mind leaps and connects ideas in a web of association, and he proposed a machine that would work the same way. In 1945, decades before the first hyperlink was coded, he had envisioned the very soul of the World Wide Web. J.C.R. Licklider, in turn, wasn't just imagining faster computers. He was dreaming of a true symbiosis, an intimate conversational partnership between human and machine. His concept of the Intergalactic Computer Network wasn't just a fanciful name, it was a bold declaration of intent for a truly global, universally accessible commons of information. He laid the philosophical and financial groundwork for what would become the open internet. And John McCarthy's prediction of utility computing was perhaps the most radical of all. At a time when computers were monolithic, priceless assets owned by giant institutions, he saw a future where computational power itself would be a commodity. He predicted that it could be delivered over a network and billed like electricity. This wasn't just a business model, it was a complete re-architecting of the economics and delivery of technology. Together, these three visionaries didn't just predict the future, they wrote its essential blueprint. It's worth pausing here to truly absorb the weight of these predictions. These men weren't just making small, incremental forecasts. They were articulating foundational, paradigm-shifting concepts that would take more than half a century to fully materialize. Vannevar Bush wasn't just thinking about a better filing cabinet. He was fundamentally rethinking the very structure of knowledge. His Memex was a direct challenge to the linear, hierarchical thinking imposed by centuries of print. He saw that the human mind leaps and connects ideas in a web of association, and he proposed a machine that would work the same way. In 1945, decades before the first hyperlink was coded, he had envisioned the very soul of the World Wide Web. J.C.R. Licklider, in turn, wasn't just imagining faster computers, he was dreaming of a true symbiosis, an intimate, conversational partnership between human and machine. His concept of the Intergalactic Computer Network wasn't just a fanciful name, it was a bold declaration of intent for a truly global, universally accessible commons of information. He laid the philosophical and financial groundwork for what would become the open internet. And John McCarthy's prediction of utility computing was perhaps the most radical of all. At a time when computers were monolithic, priceless assets owned by giant institutions, he saw a future where computational power itself would be a commodity. He predicted that it could be delivered over a network and billed like electricity. This wasn't just a business model, it was a complete re-architecting of the economics and delivery of technology. Together, these three visionaries didn't just predict the future, they wrote its essential blueprint. Key Insight 2. The Great Tug of War, Centralization versus Freedom. So the vision was there, but how did it become reality? This is where our pendulum begins its swing. The first era of computing, from the 1950s through the 70s, was one of absolute centralization. The mainframe was king. These were massive, expensive machines that lived in air-conditioned temples tended to by a priesthood of technicians. Companies like IBM ruled the world. If you wanted to compute, you used a thin client, a simple terminal with a screen and keyboard, but no brain of its own. All the processing, all the data, all the power resided on that central server. It was efficient, it was secure, and it was completely controlled. This was the pendulum stuck on one side, total centralization. Then, in the late 70s and early 80s, the microprocessor arrived, and it kicked the pendulum with incredible force. This was the dawn of the personal computer, the PC. Suddenly, computing power wasn't locked in a data center anymore, it was on your desk, in your home. This was a revolution. Apple's famous 1984 ad wasn't just marketing, it captured the zeitgeist. The PC was a tool of liberation, a weapon against the monolithic centralized authority of the mainframe. For the first time, individuals had their own local processing power, local memory, and local storage. This was the era of decentralization. The pendulum had swung all the way to the other side. But this decentralized dream quickly became an operational nightmare, especially for any large organization. This was the burden of fat clients, and it wasn't just a minor headache, it was a full-blown financial and logistical crisis. The total cost of ownership for enterprise IT didn't just rise, it skyrocketed. Let's break down exactly why this libertarian dream of localized computing resulted in corporate anarchy. First, let's talk about maintenance and upgrades. In the old mainframe world, if you needed to update a piece of software, you did it once on the central server. But with PCs, that simple task exploded into a Sisyphean nightmare. Imagine an IT administrator tasked with updating the operating system or a critical application for a company with 1,000 employees. That meant physically going to or remotely connecting to 1,000 individual machines. It was a cripplingly manual process, prone to errors and inconsistencies. And the hardware itself? The pace of obsolescence was brutal. A PC that was state-of-the-art one day was lagging in 3 to 5 years, crushed under the weight of ever more demanding software. The cycle of purchasing, deploying, and replacing thousands of machines was a constant, expensive drain on resources. Second, and perhaps even more terrifying for businesses, was the issue of data fragmentation in security. When data lives on individual hard drives, you no longer have a single source of truth. Corporate data, sensitive, critical information, was now scattered across thousands of isolated digital islands. This created a compliance and data governance disaster. How do you back everything up? How do you ensure data integrity? The answer was, you couldn't, not effectively. Even worse, the PC model gave end users unprecedented and often dangerous levels of control. With direct access to the operating system, an employee could, with a few clicks, install unauthorized software riddled with malware, accidentally delete critical system files, or, in a more malicious act, copy gigabytes of sensitive corporate data onto a floppy disk or a USB drive and simply walk out the door. The decentralized model turned every desktop into a potential security breach. Finally, there was the sheer inefficiency and depreciation of it all. PCs, with their spinning hard drives and cooling fans, were complex machines with multiple points of failure. They broke down. They consumed a significant amount of electricity, which, when multiplied by thousands of units, added up to a massive operational cost. And from an accounting perspective, these machines were a depreciating asset whose value was in constant steep decline. The financial burden was staggering. By the mid-1990s, the writing was on the wall. The decentralized freedom of the PC had come at too high a price. The industry was bleeding from 1,000 self-inflicted cuts, and leaders began to look for a way to return to centralized sanity. Key Insight 3: The Cloud's Triumph and the Silent Reformation. While Larry Ellison's physical network computer didn't dominate the market, PC prices fell too fast. The underlying philosophy won the war. The architectural argument was permanently etched into the industry's consciousness. All that was needed was for the network infrastructure to catch up. And in the 2000s, with the explosion of broadband internet, it finally did. This set the stage for the final triumphant swing of the pendulum back to centralization. In 2006, Amazon, leveraging its massive internal computing infrastructure for its retail business, launched Amazon Web Services, or AWS. It was the complete realization of John McCarthy's utility computing vision from 45 years earlier. Businesses could now rent virtual servers on demand, paying only for what they used. They no longer needed to buy and maintain their own hardware. The cloud era had officially begun. Today's cloud computing, dominated by AWS, Google Cloud, and Microsoft Azure, is the ultimate vindication of the centralized model. It combines the raw power and administrative control of the mainframe era with the rich graphical experience of the PC era, all delivered through the ultimate thin client, your web browser. The pendulum has swung, and it has settled, for now, firmly on the side of centralization. But here's the most important part of our story: the so what. Why does this 80-year journey matter? Because this shift is more than just a change in where we store our files. It represents what the document calls a silent reformation. This breaking point in the mid-90s triggered a fierce ideological and architectural counter-revolution. The industry's elite, specifically leaders at Sun Microsystems, Oracle, and IBM, began to aggressively push back against the PC's dominance. They sought to combine the administrative sanity of the mainframe era with the graphical richness of the modern age. The intellectual vanguard of this movement was Sun Microsystems. In 1984, one of its employees, John Gage, coined what would become one of the most famous slogans in Silicon Valley history: "The network is the computer." This wasn't just a catchy phrase, it was a radical, prescient vision. Sun's philosophy was that a user's desktop should be nothing more than a window into the network, a way to access the vast computing power of remote servers. To make this a reality, they championed the Java programming language. Java's revolutionary write once, run anywhere promise meant that applications could live on a central server and be executed on any lightweight client machine, regardless of its local operating system. It was a direct assault on Microsoft's localized Windows monopoly. Then, the critique of the PC grew overtly hostile. Oracle's aggressive CEO, Larry Ellison, launched a direct assault on the fat client paradigm. In 1996, he announced the Network Computer, or NC, a stripped-down $500 device with no local hard drive. Ellison famously derided the PC as enormously expensive and enormously complicated, arguing the industry was going in the wrong direction. The NC was the ultimate thin client. It would rely entirely on a central server to store files and deliver software over the network using Java. And finally, IBM, the original pioneer of the centralized mainframe, threw its weight behind this architectural reversal. They introduced their own line of hardware, like the IBM Network Station, which offered plug-and-play simplicity managed entirely by a server. Within IBM, the consensus became codified. The thin client paired with a massive back-end server was definitively the right architecture. This movement was profound. It laid the intellectual and corporate groundwork for a return to centralization. The visionaries of the 90s successfully exposed the deep financial and operational flaws of local PC computing and made the case that the network was truly the computer. Think about the printing press in the Renaissance. It wasn't just a new way to copy books. It fundamentally altered the structure of society. It broke the monopoly on information, democratized knowledge, and permanently changed the conditions under which people thought and communicated. It fueled the Reformation. Our transition to ubiquitous cloud-based computing is having a similar effect. It's a quiet but profound reformation of human cognition. Vannevar Bush's dream of an enlarged, intimate supplement to human memory has been realized on a staggering industrial scale. Licklider's man-computer symbiosis is no longer a futuristic vision. It's our daily reality. We collaborate with cloud-backed AI in real time. Our memory, our decision-making, our very ability to think has been extended outward into the network. The individual is no longer limited by their own biological memory or local hardware. We are all endpoints connected to the collective computational power of the species. This isn't just a technological shift, it's an evolutionary one. So, the counter-revolution had its champions and its vision. Sun, Oracle, and IBM had laid out the blueprint for a return to the center. But what were they actually promising? What were the tangible, bottom-line benefits that made this push for centralization so compelling? The operational advantages of this thin client, large server model were profound and undeniable, and they were designed to directly solve the three great crises of the PC era. First was the promise of a dramatically lower total cost of ownership, or TCO. This was the killer argument for any CFO. Thin clients, by their very design, lacked complex and failure-prone moving parts like spinning hard drives and fans. This simple fact drastically extended their operational life cycle. We're talking a lifespan of 6 to 8 years compared to the brutally short 3 to 5 year cycle of a typical PC. The upfront hardware acquisition costs were, of course, significantly lower, but the savings didn't stop there. Energy efficiency was dramatically improved. Organizations that replaced their fleets of power-hungry PCs with these sleek, efficient, thin clients often saw their electricity consumption drop by over a third. At an enterprise scale, that represented massive, ongoing savings. Second, the model promised radically simplified IT management. For IT administrators who had been fighting fires in the chaotic world of decentralized PCs, this was a vision of paradise. They could finally escape the nightmare of managing thousands of unique individual machines. Instead, they could create and manage a single, perfect, golden image of an operating system and its entire application suite. Updates, security patches, new software deployments, all of it was executed just once on the central server. The changes would then be instantly and universally available to every single user. This eliminated the crippling, soul-crushing maintenance overhead that had defined the previous decade. And third, and for many businesses the most critical promise of all, was impenetrable security and compliance. The thin client model was a fortress. With absolutely zero data residing on the local endpoint, the risk of corporate espionage or data loss, whether from a stolen laptop or a disgruntled employee with a USB flash drive, was entirely mitigated. The data never left the secure confines of the data center. Furthermore, end users simply could not compromise the local system by downloading malware or deleting critical files because they lacked any access to the underlying endpoint operating system. It was a locked-down, centrally controlled environment. By pushing all the computing power back into the data center, the industry had conceptually come full circle, returning to the old mainframe model. But it did so with a crucial modern upgrade, a highly graphical, responsive, network-delivered interface. It was a powerful synthesis, aiming for the best of both worlds. So, We've taken a massive journey through 80 years of technological history. What are the key takeaways from this story of the architectural pendulum? I think it boils down to three powerful ideas. First, technological progress is not a straight line. It's a pendulum. It often swings between opposing philosophies, centralization and decentralization, control and freedom, simplicity and complexity. Understanding this cycle helps us see that today's inevitable technology is often a reaction to the failures of a previous era, and it plants the seeds for the next swing. In fact, we're already seeing it with the rise of edge computing, which pushes power away from the central cloud and back out to devices. The pendulum never stops. Second, today's innovations are almost always built on the foundations of decades-old visionary ideas. The cloud, the internet, hypertext, these weren't invented in a garage in the 90s. They were dreamed of by thinkers in the 40s, 50s, and 60s. It's a powerful reminder that ideas often have to wait for technology to catch up, and that the long-term visionaries are the ones who truly shape the future. And third, and most importantly, we are living through a profound yet quiet reformation of human knowledge and cognition. The shift to cloud computing is not just about convenience. It has fundamentally altered our relationship with information, memory, and problem-solving. We have outsourced a part of our cognition to the network, creating a symbiosis that is redefining what it means to be human. Recognizing this helps us appreciate the magnitude of the changes happening all around us every single day. Today, we trace the path of the architectural pendulum from the prophetic visions of Bush, Licklider, and McCarthy through the centralized reign of the mainframe to the chaotic freedom of the PC, and finally to the triumph of the modern cloud. It's a story of conflict, of vision, and of a relentless search for the best way to manage our digital lives. The next time you save a file to Google Drive, or stream a movie on Netflix, or use any of the countless cloud services that power our world, I hope you'll think of this pendulum. You'll recognize that you're participating in the latest chapter of a long and fascinating philosophical debate. Thank you for joining me on Mindcast. If this episode sparked an idea or gave you a new perspective, the best way to support the show is to subscribe on whatever platform you're listening on. I'm Will. Thanks for listening.